Hello friends, welcome to Learner's Planet. Friends, this is our sixth session for graphs. In the previous session, we have discussed transformation of graphs, right? We have discussed how a graph, suppose fx is converted into f of minus x and minus fx and minus f of minus x. Even we have discussed about modulus graph, modulus functions also. So in this session, we'll be taking more such transformations. So let's begin the session. Now friends, now discuss when fx transforms to f of modulus of x. In the previous session we have seen modulus of complete fx. Here we are discussing modulus of f, modulus of x, right? So this is the difference, you can make it out. Now what is happening over here, suppose we have the graph as y is equal to fx. Now whether x is positive or negative, you can see x is positive or negative because of this modulus. Finally it will be converted to positive, right? Suppose I have f of minus 1. If I take modulus, still it will be f of 1. And if I have f of 1, then also it is f of 1, right? So what is happening, if x is negative or positive, the value of y will be same, right? So what you have to do, whatever is the negative part, right? Here we can see this negative part, that is the part on the left hand side of y-axis. You have to remove this part and you just take the mirror images of this part, right? Okay. Because the value of this, maybe this is fa, then the value of fa will be equal to value of f of minus a because of this modulus, right? Okay, so what you have to do, you have to remove the part that is on the negative side of x and you have to take the mirror image of the part that is on the positive side of y-axis. Okay. So friends, you can see this is the final graph when x is converted to modulus of x. Okay. Now here I take an example of sine of mod x. See, you don't have to concentrate which graph we are taking. You can consider it as f of x, right? Various curve may be asked in your exam. Any of the curve can be asked, right? So you should concentrate on curve rather than this trigonometric function or any other function, right? So precisely we are having the curve of sine x, that is this red curve, right? I just draw the basic sine curve over here. It's like this, right? So this basic red curve is actually, it's going from this way to this way as I have drawn over here. So what we have to do, we have to precisely, I just show it over here, this blue part as well as this red part is actual sine curve that we can compare from here, right? Now what we have to do, we have to remove the blue part, that is the negative part, right? The blue part we have to remove. Then what we have to do, we have to take the mirror image of this, that you can very well see. This is the mirror image, right? So when x is converted to modulus of x, the value of y will remain same whether x is positive or negative, right? So the graph which you are going to get on the right hand side of y-axis, the same graph you'll be getting on the left hand side of y-axis, right? I hope you are getting me. Now we discuss this graph, that is the greatest integer function and modulus of that, right? Box x is what? Greatest integer function, right? That we have discussed in our previous sessions. Now this is this blue part and this pink part, right? That the first quadrant and the third quadrant. That is basically the graph of box x, right? Now box, suppose I take one example. If I have maybe say 1.2. So box 1.2 will be 1 only. Now suppose I have modulus of or maybe suppose I take minus of 1.2, then what will happen? It will be minus 2, right? Now if I take modulus of the number, right? So this is minus 1.2, right? Now what is happening over here? If it comes out of the modulus, this minus 1.2 will be converted to 1.2 only, right? Now 1.2, box of 1.2 will be 1 only, right? So whether x is positive or negative, y will be the same, or fx will be the same, right? So what we have to do, the portion that is negative, we have to eliminate that portion, and we have to take the mirror image of this function or this graph that is on the right hand side of y-axis, right? So you drop this part, retain this part, and just draw the images, right? This corresponding images you draw over here. Okay, so it's very simple to convert a box function into its modulus function. Okay. Now friends, let's discuss this graph. That's modulus of x square minus 4 mod x plus 2. For that we need to draw this graph, that is x square minus 4x plus 2. Now this is a square function and that represents a parabola, but its origin is shifted, right? Now how do we draw the graph of x square minus 4x plus 2? What you can do, you can convert it into a quadratic function like this, right? So this what you can do is x square minus 4x plus 4 minus 4 plus 2. So this is x minus 2 whole square and this is minus 2, right? I have added 4 and deducted 4. Now this x minus 2 whole square minus 2. Now if you are having x as 2, right? If x is 2, y will be minus 2, right? So that will be that's when x is 2, y will be minus 2. That is the minimum value of this function. Okay. If you are having x as 1, then y will be 1 minus 2 whole square, that is 1 minus 2, that is minus 1, right? So if you are having x as 1, y will be minus 1. So that's this point, right? Similarly, if you are having x is 3, then it is 3 minus 2 whole square, that is 1 minus 2, still y will be minus 1. That you can see from here, right? So this way the complete graph can be drawn, right? When x is 0, so when x is equal to 0, then y is equal to 2, right? That is this point. So this is the graph that we are going to get for x minus 2 whole square minus 2. Now as we have discussed, if it is the x is converted to modulus, what you have to do, you have to eliminate the part that is on the left hand side of y-axis. So we have to eliminate this part. Now on the right hand side part, that is this part that is on the right hand side of y-axis, you have to retain that part and you have to take the mirror image of this. Just as it is, you just draw that. Very simple, friends. So we'll be getting a shape of W over here that will represent this graph. Okay, so it's very simple. When x is converted to modulus of x, what you have to do? Precisely, you have to retain the part that is on the right hand side of y-axis. You have to eliminate the part that is on the left hand side of y-axis. Now whatever the part is left on the right hand side of y-axis, you have to take the mirror image of that, right? So you'll be able to get the graph of when x is converted to modulus of x, right? Now here two things are happening simultaneously. X is converted to modulus of x and complete modulus is also taken, right? So what we have to do, first of all, we have to draw the graph of fx to modulus of fx. Then from modulus of fx to modulus of f to f of modulus of x, right? So how it happens or how it is done, let's discuss by taking an example. Now suppose I have this graph that is fx. Okay. Now what we have to do when fx is converting to modulus of fx, as we have discussed in the first step, that the negative part that is below x-axis has to be eliminated and we have to take its image, or we can say water image of this we have to take, right? So you eliminate this part and you put it like this. So now fx is converted to modulus of fx. Now what is the next step? You have to remove this part that is on the negative side of y-axis, on the left hand side of the y-axis, and you have to take the mirror image of this part, right? Getting my point? I just repeat it once again. When you are converting fx to modulus of fx, this is the graph of fx, right? When you have to convert fx to modulus of fx, eliminate the part that is below x-axis and take its water image, right? So it will be converted to this. Now we have to convert this to this, right? That means x to modulus of x. So we have just discussed what we have to do. We have to remove the negative part, or the part that is on the left hand side of y-axis. So this part will be removed, and we have to take the mirror image of this. So that will be something like this. Okay, if you draw neatly, you'll be getting the perfect graph, right? I just show you how it is, how it looks. So you can see over here, we have deleted this part and we have taken the mirror image of this part. So this part is as it is and the mirror image of this part. So this is the conversion of fx to modulus of f of mod x, right? Initially you deleted the part that is below x-axis, then you deleted the part that is left hand side of y-axis, and finally you are getting this graph, right? Friends, here I am having a question from previous year CAT papers, when the question was asked, like, which of the following is the correct graph of this function, this given function, right? So what are the steps you need to follow? First of all, if you draw the graph of x minus 1, you'll be getting a straight line. How do you draw a straight line? Just find out when x is 0, y is 0, right? When x is 0, y is minus 1. That is, the line will pass through 0, minus 1, right? And when y is 0, x is 1. That means the 2 points you are getting. Now you can draw a line that is passing through these 2 points, right? So this is the graph of x minus 1. Now what you have to do, you have to convert that to modulus of x minus 1. That means the part that is below x-axis has to be eliminated, right? And what we have to do, we have to take its water image. So the graph will go like this. So we have to eliminate this part, that is, I have shown you over here. So this part is eliminated and we have to take the water image of this part. Now this is the graph of y is equal to modulus of x minus 1. After that, what we have to do, we have to convert this x to modulus of x. That means we have to eliminate the part that is on the left side of y-axis. So I eliminated that part. So this part is eliminated, and we are left with then this part. That is this part, right? Now what we have to do, we have to take the mirror image like this. So that I have shown you over here, right? This part is eliminated and I have taken the mirror image of this part. Okay, so it's very easy. You just need some practice, right? And conceptually you should be clear why it is and how it is happening. Okay. Now friends, let's draw the graph of this function. Here, first of all, we have to draw the graph of e raised to x minus 2 minus 4. You must be knowing the graph of e raised to x, that's this, right? Y is equal to e raised to x. So when x is equal to 0, y is equal to 1. X is 0, y is equal to 1, right? So this is the point 0, 1, right? And the value of y will never be 0 because e raised to x will never be 0, right? So the value will be the curve will be closer and closer and closer to x-axis, but it will never intersect x-axis, right? That means y will never be 0. Now if we convert from x to x minus 2, the graph will shift 2 step right hand side, as we can see over here. So 2 step right hand side. Okay. After that, if we deduct 4 from it, the graph will shift 4 step downwards. Getting my point? From this point to 4 step downwards, that we can see over here. Right? So it's 2 step right hand side and then 4 step downside because of this minus 4. So this transformation we have already discussed in our basic sessions. Now here what we have to discuss, first of all we have to find out the modulus of this complete, that means modulus of this. So what we have to do, we have to eliminate the part that is below x-axis, right? That means this complete portion will be eliminated, right? That you can see over here. So this complete portion is eliminated. After that we have to take the water image of this part, right? We have eliminated this, and the or you can say this, you consider this as mirror and take the mirror image of this part, right? So modulus of e raised to x minus 2 minus 4, this is this graph. After that what we have to do, we have to eliminate the part that is on the left hand side of y-axis, that means this part will be eliminated, and then the remaining part is this. This is the remaining part, and we have to take the mirror image of this part. So finally the graph will look like this, right? So friends, actually it is very simple. You need some practice, right? If fx is converted to modulus of fx, then you have to eliminate the part that is below x-axis, and you have to take the water image of that. And if fx is converted to f of modulus of x, then you have to eliminate the part that is on the left hand side of y-axis, and you have to take the mirror image of the part that is right hand side, that is on the right hand side of y-axis. And in this case, when f of x its modulus and overall modulus, then you have to consider both the things, right? So if you do some practice, it will be very easy for you. Now friends, let's see some more transformations over here. Here, when y is equal to fx transforms to modulus of y is equal to fx, when y is equal to fx transforms to modulus of y is equal to modulus of fx, and y is equal to fx transforms to modulus of y is equal to modulus of f of modulus of x. Seems to be tedious, but it is not at all tedious. You just have to follow certain steps. After that it is just a cakewalk, right? So let's take a few examples. Now here, how do we start? Just listen to me carefully. When y is equal to f of x transforms to modulus of y is equal to f of x. Now what is happening over here? See, modulus of y, that means it is a positive quantity, right? That means f of x is a positive quantity, right? So that means f of x, if it is less than 0, then the graph of modulus of y is equal to f of x will not exist. Obviously, because f of x, if it is less than 0, that means the part is there on the below x-axis, right? But that will not exist because fx is positive. Okay, so and if fx is greater than equal to 0, then modulus of y is equal to fx would be given as y is equal to plus minus f of x, right? I just take example. After that it will be cleared. Instead of discussing too much theory, let's take an example. Now just see carefully. We have this graph of y is equal to fx, right? Now if I have to convert y to modulus of y, then what will happen? Fx will be a positive quantity, right? Fx will be a positive quantity. So the first step, we have to delete the part that is below x-axis. This part we have to remove. Now what is the next step? We have to take the water image of the positive portion. Now why it is happening? Just listen to me carefully. Suppose f of x is 1 and f of x is minus 1, right? So if you take modulus, so modulus of 1 is 1 and modulus of minus 1 is 1, right? So when y is negative or positive, fx will be positive, right? So y, so see, we can see over here y is minus 2 and here y is 2. In both the cases the value of fx is 2 only, right? That means this portion, right? You can see. So whether y is negative or positive, doesn't matter, the same graph we will get, right? So what we have to do precisely, first of all, we have to remove the part that is on the third quadrant, or we can say negative of x. Then we have to retain the remaining graph and we have to take the water image of that graph. So modulus of y is equal to fx graph we will be getting, right? I take one more example. Suppose we draw the graph of y is equal to modulus of y is equal to sin x. For that we need to draw the graph of y is equal to sin x. So this is the graph of y is equal to sin x, right? When x is 0, y is 0. That means the graph is passing through origin, right? The portion that is below x-axis gives the negative value of y, right? So this between minus pi to minus 2 pi, y will be negative, right? Similarly, between pi to 2 pi, y will be negative because sine pi is 0 and sine 2 pi is also 0. So sine between these two, maybe 3 pi by 2 we can take. So that's the negative one. So this is this value, right? So between pi to 2 pi, sine theta is negative. So this is the graph that we are going to get for sine x. Now we have to convert it to the modulus of y is equal to sine x. So what the first step we have to follow? Just see carefully. Here, this blue part we have to remove, right? This is the graph of sine x, right? From this we need to remove this blue part. Okay. So precisely which part we are removing? The part that is below x-axis. Part below x-axis, right? So that we are removing. The next step is the remaining portion, whatever is left after deleting this, we are left with this, then this, and then this. Now the next step is we have to take their water images. So water image of this is this, water image of this is this, and water image of this is this. As simple as that, right? So this graph converted to modulus of y is equal to sin x. Just further we make the comparison. This is sin x graph, right? We have to eliminate the portion that is below x-axis. Then for the remaining portion we have to take their water images, right? So that will be converted to modulus of y is equal to sin x. Now suppose we have to draw the graph of modulus of y is equal to x square minus 4. First of all, we'll draw the graph of x square minus 4. For that we need to draw the graph of y is equal to x square. Then it is minus 4. So it's 4 step down, right? So graph of x square, that is y is equal to x square is this. Then x square minus 4, that means 4 step down. So this is the 4 step down. So this is the graph of x square minus 4. After that, what we have to do? We have to eliminate the portion that is below x-axis. That means this is the portion that to be eliminated, right? After that, this portion is eliminated. We have to take the water image of the remaining part. So remaining part is this, so this way. So you'll be getting this as the final graph. Getting my point? Very simple. First of all, we draw the graph of x square minus 4, eliminated the part that is below x-axis, and for the remaining part we have taken its water image. Okay. Suppose we have modulus of y is equal to log x. So for that, first of all, we'll draw y is equal to log x. The graph we have already discussed in our basic graph sessions. So this is the graph of y is equal to log x. Now this is the part that is below x-axis. Eliminate that, and what you have to do? You have to take the water image of the remaining portion. That will be something like this, right? So the final graph will be this as well as this. I just show you over here that. Okay friends, so this is the final graph. So friends, in the next session we'll be looking at more such transformations, and I hope you are getting the concept of graphs, and I'm sure you find it interesting as well. So I'll see you in the next session once again. Bye bye.